So this lesson is going to be topic 2.2, standard form of a quadratic function. All right, so yesterday we talked about vertex form, which is extremely helpful. Standard form is okay. It's not as helpful as vertex form, but that's okay. So standard form is going to be the form f of x equals ax squared plus bx plus c. So a, b, and c are going to be numbers when we have the actual function. And we talked about this a little yesterday, but a quadratic equation creates a U-shaped curve called a parabola. All right, so these first two examples, we're just going to use a calculator to do. So let's clear it out. All right, so we're going to type in each of those. Okay, and then we're just going to do a little sketch of that graph. It doesn't have to be perfect, just kind of similar shape and a similar position. Okay, and I'll get the other one too. Okay, so it looks something like that one. All right, so if you notice, in this first one, the number in front of x squared is what's considered a. So in this one, a is positive 1. A is positive, then the parabola will open upward, which is what happened. All right, and then for the second one, a in this case was negative 1. And when a was negative 1, the parabola opened downward. Okay. All right. So a vertical line that divides the parabola in two equal parts is called the axis of symmetry. And the axis of symmetry formula is x equals, I'm using the wrong thing, sorry. X equals the opposite of b over 2a. All right, so for example, on this one, A we already said was 1. B, in this case, is the number in front of X. So B is 2. So if we were going to find the equation of the axis of symmetry on that one, it would be X equals the opposite of B, so negative B over 2 times A, which is going to be X equals negative 1, which is this. If I drew it perfectly, that would be the axis of symmetry. It's the line x equals negative 1. Okay. All right, and then the turning point of a parabola is called the vertex, and we talked about that yesterday. The vertex is the lowest point. When it is, it's called a minimum, and when the vertex is the highest point, it would be called a maximum. So in this case, the vertex is a minimum. And in this case, the vertex is a maximum. Okay. And then this one, the axis of symmetry, would be that right there. Okay. So on our examples, we're going to determine whether each function has a maximum or a minimum, and then find the axis of symmetry and the vertex. All right. So in this first one, A is 4. So if that's positive, it's going to be a parabola that opens upward. Therefore, it is going to have a minimum. Okay, so now b is the number in front of x. So in this case, b is 0. And to find the axis of symmetry, we're going to say the opposite of b, x is the opposite of b over 2a. So x is the opposite of 0. Well, 0 doesn't have a sign. So this is going to be 0 divided by 8. And 0 divided by everything except 0 is 0. Okay? And then we're just going to let the calculator help us find the vertex. So we'll go in and we'll put it into y equals. And we'll go to our table like we did yesterday. So second graph. And we know that, well, it's already ready for us. We know that the x part of the vertex matches the axis of symmetry. And so what we would do is make sure we put that in the middle. And these two are the same. So our vertex is the point 0, 0. Okay, so let's look at the next one. Okay, so on this one, I would start off and I would say what a is. A is -1. It's the coefficient or the number in front of x squared. So because it is negative, this is going to be one of the ones that opens downward, so it will have a maximum. All right. B is 6 because it's the number in front of x. So I'm going to use my axis of symmetry equation. X equals the opposite of b over 2 times a. So x is -6 divided by -3, or just 2. All right. So I know that the x part of my vertex is going to be 2. So I'll go to my calculator. I'll plug in the function and go to the table. Now what I want to do is scroll around until I get 2 in the middle. Okay. Oops. Just kidding. I messed up. Hold on, let's fix this. That's a good reason to use your calculator, because somehow that 2 turned into 3. So it should have been 2 times -1 is -2. -6 divided by -2 is 3. So that is x equals 3. So the x part of our vertex is 3. Sorry about that. So I realized my mistake when I looked at the graph. I looked at the table. So I know the vertex is in the middle when our top and our bottom are the same number. So that's going to make my vertex be the point 9. Oh, sorry, 3, 9. Okay, so let's look at number 3. A is -2. So because A is negative, I know I'm going to open downward and have a maximum. B is the number in front of x. Well, I don't have an x, so in this case, B is 0. So our axis of symmetry, x equals the opposite of b over 2a. So 0 divided by every other number besides itself is going to give you 0. So this one, I'm just going to plug it in my head. So if the y part of the vertex is going to be what this equals, when x is 0. So when x is 0, this whole thing right here becomes 0, and you're just left with 7. All right, so one more. A is 1, b is -8. X equals the opposite of b over 2a. 8 over 2 is 4. Oh, I forgot the first part. A is positive, so this one opens upward, and we have a minimum. Right? If you wanted to, you could take that 4, plug it into these x's and see what you get. But if you're going to do that, you might as well just go ahead and get the table. It's a little bit more difficult to do in your head than the last one we did. All right, so I do know I want 4 in the middle. There it is. These two numbers are the same, so I know that middle is my vertex. Okay, so your assignment is to do those things that we just did, but also to get the graph like we did yesterday and do the domain and range, which we haven't done. So let me just talk about this for a second. So this one that we just did, this minimum is going to be at the point 4, -7. So it'll be something like this, where you go 4, and then this is at -7. So for the domain, if we were going to do the domain, we have an arrow going to the left and an arrow going to the right. So that's going to make our domain be all real numbers. In every quadratic equation, the graph is a parabola that has an arrow going to the left and an arrow going to the right. So all of our domains are going to be all real numbers. All right, and then for the range, this one we do have a very bottom number. So the bottom number is -7. So we're going to go from -7 to infinity on our range. All right, I do want to do one more of those. Okay, so here's one that's upside down. Our vertex is at the point 0, 7. So this right here is 7. So for the domain, arrow going to the left, arrow going to the right, all quadratic functions. The domain is all real numbers, -infinity to infinity. All right. And then for the range, we have an arrow going down, pointing towards -infinity, and our top is 7. The highest y we'll get to is 7. Okay, so that's just a little refresher on doing the domain and range on the graph. So your assignment is to complete that worksheet.